This is recording. I think we're set to kill it. Oh, checking to see. Yeah. Take my hat to from tech to wildlife management expert. You guys are just about to be experts in wildlife management. We've covered quite a few directions. Remember, global approach. Many people, including the textbook that some of you might have got from Porter, are all American style. So the content is actually biased to some degree by the USA situation, whether it's access to databases, whether it's spatially explicit models and stuff like that. So I took more of a global approach, as you can see, just because I'm trying to gather 42 people into the same topic. So some people like koalas better than belugas. So we can't help that. So yeah, I'm basically just an entertainer. Yeah. Now, talking about entertainment, breaking news, we might be finishing the material before December or 2020. So I came up with another short chapter on habitat selection. I thought it was really important to set some basis about that because it's such a recurrent aspect. And again, there's different ways to approach habitat. So landscape is definitely, you know, like maybe a fifth, a quarter of the material that we've seen. Remember that we started with something like more of a taxonomic review just to set the basis on. And then we classified these animals depending on their interface with humans. But everywhere in there, whether it's numerous, you know, super abundant wild boar, or if it's endangered koala, at some point, any one of those species might be targeted by habitat loss. So the whole topic becomes recurrent. That means every possible wildlife manager will think about wild boar, the animal itself, deal with numbers on the wildlife, but also at the same time probably take care of the habitat. So it's a very important topic. I hope you appreciate that. So landscape ecology is more of a newer field. We've seen that already. Remember that you want to boil it down to whatever is highlighted in those slides. The text is for you to have good memories about this wonderful class. Heterogeneity is exemplified by this. So of course, for the final exam, straight questions are, here's a picture. What does it say? And it, where do you think you found it? And here's a breaking, maybe for the first time in your program, somebody's going to dare asking names of authors. Oh, look at that. Half of the names you can pronounce are in your orals. They're coming up. Just because we've handled a few and it just looks fantastic when you can say Porter 2021, Porter et al. 2021. We can say, you know, different names. We're not seeing 100. So I'm going to point out, after we finish the material, I'm going to point out two key authors. All right. So again, I imagine you sitting down for an interview and say, what textbook did you use for LM? I was Porter et al. 2021. So you don't know the name? Oh. And then, oh, we didn't cover it all. So we covered a few chapters from 5 to 10, and then there's probably each in there for the short names at the exam, not the complicated ones, because then spelling becomes an issue. Yeah. Okay. So clearly, this shows heterogeneity. from left to the right with no habitat loss. So the same number of cells, if you like, in a grid. We can use that in landscape patterns, right? So cells, because it's a term that's very recurrent in databases, electronic databases that we're going to be talking about in a few moments. So now the key here is that you can't dismiss one and go for the other. So that means that heterogeneity is offering all kinds of patterns. So I second thought. This is good, and this is good for different species. This one offers a patch size. You see that? Remember that? Large patch size. Very little edge compared to this. That kind of feature. Different configuration, spatial patterns, call it whatever, that's what the landscape is all about. So it really, it's getting closer to geography, definitely. But I mean, this is what animals respond to is configuration. Every moose around, raise your hand. Skeet, anybody? Raise your hand. Oh yeah, numerous. Nobody knows skeet. Sudbury Airport, raise your hand. Yeah, there you go. So every moose around the region knows there's an airport and they have corridors around it. So they respond to the spatial pattern. So remember exactly where we are for slide number here, but chapter 5 is by Beach, 2021, of course, one chapter. I'm trying to boil it down. This is a textbook where people like to talk and talk. So right-hand side there, the legend, I bold it down to the left. This is important. There's going to be a question of, at least 10 points on acronyms, right? List of acronyms. So of course your job is, if you're shown 12, it's not to panic. Don't hold your breath. Wildlife management area, very, very common in any kind of literature. Wildlife management area. Another way of asking the question, what do we call it in Ontario? What do we do? This is US, yeah.
Wildlife Management Unit.
Yes. WMU is Wildlife Management Unit. Hey, listen, we're not going crazy. It's just that if you are seeing this, it's going to help your reading on wildlife management. Sure. Obviously, in Texas, I didn't know they had some kind of forest here, forest, shrubland, and grassland patches. In brief, in that same wildlife management area, they're showing that two sources will give you two different pictures. So this is a different database. Obviously, for we're going to say plant cover, general in A, and in B, soil topography and management. And obviously, the two pictures, without going into details, are very contrasted. That means that if animals respond more to plant cover, this is their pattern. This is what they're seeing. If the animal responds more to soil, I can think of animals who like soil. Anybody? Anybody who goes for special soils and any kind of wildlife that you would know? Yeah.
What was the question for?
What kind of animals care for soils? I don't think the wolf too much, but
Like the ones that burrow, so like rabbits and things?
yeah, like what?
Like rabbits or?
Yeah,
other things?
rabbits are not good diggers, but
Yeah.
they're not a very good digger. They go for natural cavities under a branch and so on. But you're right. All the burrowers, yeah.
Prairie dogs. moles.
Yeah, absolutely. So around here would be the groundhog. The groundhog needs a certain drainage. It's not good to be flooded. Bonus point. What is the name of the town that's being flooded? BC. No. Nobody follows the floods around. Just COVID. That's it. Abbotsford. That's right. Abbotsford is being flooded because they got 25,000 people who decided to use a floodplain. And they made channels to drain it because it's beautiful when it's dry. It's dry now. You look it up on Google Earth, it's phenomenal. It's a one valley that goes all the way to Vancouver. So up it's about 50, 100 kilometers away, and the whole thing is getting water from the US even. So, again, this is just very quantitative, so a very short story at the exam. For if I show you the picture, this is a contrast between two data sources. One is plant cover, and the other one is soil, call it elevation is a good answer, topography, and management. This is in Texas. I don't know what kind of elevation we get. Same chapter right here. I'm going through some of the pictures, the figures that they showed. This is showing a direction of, we went through this already, right? Went through this already. So some keywords are propagule is a general term for anything that disperses the plant. Of course, seeds and so on. And that comes from in-type vegetation. So the fire, again, we're to spatial patterns. There's a way to apply burns. One is a line like this, and this one creates more different succession. Did I say that last time, Michael? Different succession. That means you have the patterns of plant composition. So makes a big difference, and this is what plants like. What this case. So very quickly, same idea about soils. Just showing that you can classify. Remember? Oh no, you don't remember. I never thought of it, but yeah, soils, lots of material in the soil. So right here, we're just going to extract a few. The names of a few data sets. Some that you know. NASA is a good thing to keep in mind. NASA comes around right here. This graph right here shows some data sources. So very quick, couple point question at the exam. Can you name satellite providers? So satellite data providers. So NASA definitely. Why are there so many? The answer, yeah, because these are just a few, and remember, Porter et al. Is American, so of course, American, I'm sure in Iran, different databases. But why there are so many is because the resolution is different. So 30 meters, I don't need the numbers at the exam, but the idea is that different databases give you a different. What did I say for a resolution again? For the term I'm using all the time for resolution. For example, the size of the pixel, size of the patch, all grain size. I use that all the time. All right. So different grain size. This one's quite high resolution right here. I don't need to know which one is high resolution. That would be lab material if we were to get there. And aerial photos are can be pretty good as well. 1 meter. All right. So you got at least 3 right here. And also just add something else in the descriptors of why the question is why are there so many? It's because also the recurrence is different. So the periodicity, call it what you want. Some don't come around too often. This one's 16 days. This one's every 1 or 2 days. Depending on which. And again, I don't know which one does what. But the idea is to keep an open mind on new databases coming up because they have this kind of different profile. For example, being free is not a bad feature. All right. That means that tomorrow somebody can start using some databases. There are some databases out there. Just like GPS, it costs a fortune. So, open. It used to be closed for the army, so the army would allow you to know exactly where you are if you're sitting on the side somewhere. So. All right, so LiDAR, another name to remember. Again, that's satellite. LiDAR is very common in the literature. Just showing two layers. So here's a new term for the exam. So in GIS, right? You got layers, right? So you have the values to some points on the map. You put the layers that you think matter for your analysis. In this case, this one shows elevation, and this one shows vegetation height. If an animal requires both layers are important. So I think this is very easy to understand. And it's just showing that you got to keep an open mind on classification as well. So in other words, you got to find out in your next job whether elevation matters for what your target species is. Elevation, for example, it could represent drainage and, of course, vegetation cover. Here's another example of classification of different habitats. And again, you play around with those values. So you receive numbers of almost like an address book for a given city or town. And you have to classify, you have to boil it down to some significant habitat values right here. So in this model right here, no vegetation, the open water, you notice that ice is in there as well, so it's just classified as non-vegetated. Develop is pretty interesting right here. I like it because I never knew how to classify a 10-story building from a 2-story building. I like this. Very long time ago, I had a student come from France wanting to do a master's on Canadian species. Came in thinking she could do river otter. So we ended up working on European river otter, looking at the landscape in Europe. See if there was any chance that we could detect what drives the river otter. And of course, population density readily available on the web. And keep that in mind. In your landscape, humans are never too far. Therefore, this becomes very important. So open space is something that maybe an old field. Low intensity is a small density of people, right? So if you want to use that metric, is number of people per unit area, I guess, medium and high. So I like this this thing right here. High intensity might be everything that comes with development. All kinds of disturbances when we move their guides. All kinds of disturbances. Machinery, noise, collision risk, because we shoot anything that comes by. I like this. It needs a big no, agriculture, and then natural is right here. All right. So that's one more thing. Now that was very quickly. So that was a Veach at first, and then Diamond and Elliott, chapter 6. Just extracted what they thought was important, so it was important. This one is by Fred Bastille Rousseau. Right here. Oh, yeah, 2021. Obviously, a graph that's just showing a scientific approach. So, in brief, very quick answer. This represents science. From certainty of conclusion is pretty interesting, of course, is what's highly uncertain. That send you a big picture and said, was that a clue? So that would be descriptive natural history, just one observation, and that's it. And certainly is when you have a laboratory experiment. This is something that I teach in other courses as well. So if you approach science, I mean, Darwin's work, if it was still there, we have the original drawing that's on, is good science. Dr. Alary. Anybody knows Dr. Alary from maybe? Yep. Yeah, I think he published a drawing because he just found a new hair on the sixth leg of something. So it's still valid. It's over here, but the idea is that to eventually you can improve. He's going into several species, so he's getting into a large inference. You want this for the exam for your class? Inference means extrapolation. You keep it simple. It's like how much can you extrapolate? I sample color of shirts in the room, and I happen to see only Adam. I include everybody's wearing red. Right? So I cannot extend beyond what I've seen. All right. So of course, the more you observe, the more you got inference. You can generalize. You know, I mean, Darwin saw 30 islands. That's why I said there's something about islands. Therefore, he extrapolated to islands in general. I do that for a coffee cup. I say, oh, look at this, fantastic. Look at this. There you go. Put it down. I say, this is very good. Oh, look at this. Almost, eh? So I just generalized. I made an inference from two observations. All right. So you extrapolate, you generalize, all right. So term very common, and some papers have a small inference because it was just done, you know, in your backyard. And the same for this area right here is when you don't control, and I'll make it simple. Right here, you don't control anything. You just saw cougar, took a picture. You never control anything, and you might never see that again. And then eventually you might want to do experiments where you change and control every variable. So that's the spectrum we got. What is not showing here, so I'll rewrite the book. In between is what we call the comparative. Never mind the pseudo replication right here. Not very impressive. But field studies when you do comparative. So forage versus prairie versus forage, you repeat that all the time. All right. All right. So from descriptive, I call it also qualitative, correct? So just a drawing, for example, just valid. Comparative, never mind the pseudo replication. Comparative is the midway, is better than just descriptive. You know, you look at a deer, so look at the antlers and so on, and say, I wonder if the antlers are always the same. Go to the next species and so it's comparative. And then simulation is when you want to control every variable and pick the ones you want to vary: temperature, pH, whatever. It could be sandwiches, fish tank, for example. You mix in 2 species, 3 species. You change the conditions, but you reverse the conditions. So this is something people really forget. I control every condition. Yeah, can you reverse the condition? Can you go from 5 species, certain community, bring it down to 2 voluntarily, remove 3 species, and bring it back to 5? So that's a real simulation. Same chapter right here, chapter 8 in that textbook, the choice of grain size relative to species, nothing new about this, all right? So this is just 3 pictures showing that. And that's the beauty, actually, is that the same databases contains all 3. All you gotta do is program GIS. very important to determine right off the bat. If you're thinking of a very small species such as what small species we talked about in the liquor review that I provided in the previous PowerPoint. I had some beach mouse, pretty small. So grain size pretty small compared to a larger animal, and we're gonna get to that at some point. Animals that use a lot of space. All right, so just showing of course different patterns. So again, I removed the legend. I show the pictures. I want to know what's the story here. And it's a different grain sizes provided by GIS. So depending on the species I'm interested in. Obviously, this one is finer grain size, and this one you can tell from the series right here. That's going to be at the exam right here. So you're looking at this. I classified, I don't know, 2, 4, 6, 8, 10, only 16, 18 to 8, and then to 4. Collapsed. Coalesced. Right. I think you're familiar with that. I boiled this down because there are some people are ambitious. Say, Frere and Bessie, Husso. Yeah. Page 120. I want to introduce 2 terms that relate to GIS. And the GIS specialist will ask you some questions. You go through an interview. He says, I want to study wolves. He wants to know if you're going to have a sampling at spaced intervals, or if you're going to be doing continuous sampling, which is a sort of an all occurrence. If I'm looking right here, I can sample the floor. If the tiles represent different habitats, I can move every 100 meters and whatever is there, I read. That gives you a grid. Because watch this, I'm moving to the next one, and the whole thing now is whatever color I saw right here. Saw that? So that's a grid. So it's categories. And then continuous is all occurrences. So, whoa, what did I just see here? Oh, same. Oh, look at a new one. Different approach, right? 2 terms to remember. So 2 ways to present data to a GIS, and by categories or continuous. And of course, they give you different attributes. I don't care for those. Those are the only 2 terms I'm interested in. 2 terms somewhat related to that GIS are called raster and vector. So that's the kind of jargon that your GIS specialist is going to tell you. Let's see. Oh, grid, you mean raster? Yes. Continuous means vector. All right. So they're equivalent. And of course, this is the absolute limit of my knowledge in GIS. Every biology department, every science unit should have a GIS, geographer of some sort. Very useful, very universal as well. Every species of habitat. R is to bring to the exam. You all know that's very familiar by now. I'm sure if you talk Dr. Liskus, probably said that in the briefs. So we're in many of our colleagues in biology have always advocated our training approach. Tell that to your next floor. Just say, sorry, I came from Laurentian Delaware. That you don't have our knowledge. You might. There's some private consulting companies that offer the program, but then it's package you pay separate and so on. So I'm not exactly sure. I try to publish without if I can use R, but I'm not recommending this. So I strongly recommend that you get to programming R. That thing R, when I think about it, was embryonic when I was doing my grad study back in Montreal. There was a famous biomath lab, famous author, super productive scientist, and so on. He had the technologists work on that software. Got much better. So R includes, and you want this for the exam, because we're talking habitat. So question, of course, is what kind of software would you use for fragmentation? FragStats is on R. Never mind the other ones, I just want one. Again, I'm not a specialist. You will not become a specialist in these yet. So nothing too surprising about attributes. That gives you something about landscape, the spatial configuration, patch size, and perimeter, or edge, same thing. ArcGIS is very important as well. So just a different acronym for GIS, very common. And then you see R also offers you some stats as well. Let's see, and that's it. That's it for me because I don't know the rest of them. But this is just a reference if you happen to wonder what the software is going to change by the month. So let's see in the month what comes up. The principles of GIS is multiple layers, obviously. So suitable elevation, we're supposing in that study area that it's everywhere is good. This one has the bottom one in terms of land cover. This is only suitable partly, same for the two next layers. You pile them up and you give suitability index. Remember that these variables are key. You don't pick anything random, you pick layers that fit the wildlife. An easy one is koala eucalyptus. Yeah. So maybe a eucalyptus layer would be appropriate, something like that. Another consideration, we're now in NEMA 2021. Never mind Untitled Chapters. This one reminds us that when you're studying habitat, you have to find out if you're into the core habitat in the distribution, if you're into the marginal habitat. So those are the two terms you need to remember. I don't know why they show an overlap right here. So that's a different issue altogether. But this is basically, as you can see here, the dark is showing high habitat quality, the center. When you think about it, it just makes sense, right? That the center of any kind of distribution would be the optimal conditions. Am I right? The rest is all marginal distribution. Am I right? Yes. So there's a limit north to the gray wolf, I guess, switches to Arctic wolf. So marginal conditions, the ones that are just on near the Arctic are probably suffering. When you gray wolf and you're approaching Vaughan or Toronto, pretty marginal as well. And when you get into maple forest, pretty marginal as well. So therefore, the animal has a distribution, and the center of this distribution should show optimal conditions, meaning if there's the best that can be for species A and species B in dark, and then the rest, the edge is marginal condition. All right. So just something in the background to know. For example, if you wanted to establish deer country here, if I'm working in the ministry, I want to work on white-tailed deer, I'm not running to Sudbury because their snow conditions will not be good anyway. This is marginal habitat for white-tailed deer, right? So different consideration. You got to know where you're concept about the species distribution. All right. Concept of umbrella species been used a couple of times. So Nemeth et al. Uses it right here. Concept of umbrella species, we've talked about it. This is probably third time I talk about it. Umbrella means it, of course, it oversees every other species. And for the longest time, people say, if I can only measure one species, I would know what's out there. And that's an umbrella species. And I want to find a species that represent the most richness below them. The rich examples right here. And this is really the habitat. So of course, the question is, okay, I want to reintroduce forest patch. I'm counting on the woodpecker to tell me when that patch is appropriate. So I build the first patch and I get downy woodpeckers, and then build another one, then I get another species, and then I get the pileated. The pileated will be your umbrella species because it's minimum patch size, right? As your patch increases in size in hectares right here, you are likely to increase to satisfy requirements for picky animals, the one that require the largest patch size of them all. The downy, 1 hectare. Can't think of the names right now, but another one, medium size flicker, for example, will be 4 hectares, and then suddenly pileated will not tolerate anything under 20 hectares. This is what's represented right here. Once we know that, once we know the habitat requirement, it's okay, I want to establish patch size after logging. Which species should I go by? The idea is I'm going to go with pileated because it will cover the other one. All right. Umbrella for, that doesn't mean the full protection. It just means that this animal is likely to include the other ones because it's the pickiest of in terms of patch size. This is so that was Nemut, and here's Keller, chapter 15, showing one interesting picture showing that all edges are not exactly the same. So write this down, and that's something. It's just fine tuning the idea of edge. So in landscape configuration, so far we talk about habitat, matrix. In between, we have a net. So right now I'm thinking of complications in the real world when your transition is gradual. What do we call this again? Transition that's gradual between two ecosystems is a necatone. So you got this down somewhere. Then even in edges, edge is abrupt, right? The ecotone is gradual. But even in edges, the transition might be a little different because you might transition from this kind of pattern to this kind of habitat. All right, so that's all it says right here, is that all edges are not necessarily exactly the same. Think of a forest bird, for example. Kingfisher, the branches over, suddenly the edge is not the same. By the river. This picture, same Keller again, showing changes in forest bird gills following clear cutting. And this shows the density right here in pairs per 40 hectares. So I guess it's not very, and that's avian gills. I noticed the term, that's why I retain this. Oh, what do you call this? Make it easy. I call my group mesocarnivores, just to keep it simple. So gill is about the same thing right here. Functionally related species that are sympatric. Omnivores is a gill, mid gleaners is a gill, low gleaners, and those are terms I don't use. Only when you know birds real well. Low gleaners are over 3 meters and so on. So they're different gill, obviously affected by clear cutting. Obviously, because there's no more high gleaning anyway. So here's another picture quickly that's showing that again, spatial patterns mean a lot. I got 2 habitats, one black, one white. Different patches, of course. On the right, I just have exactly the same thing, except for the other fancy term, interspersion. Interspersion of the 2 habitats. That means they sort of mingle on the right-hand side. See that right here? So obviously, I'm sure I reduced the connectivity. I used to have good connectivity here, a little less right here. But that will satisfy different species. Here's a landscape as I think about it when I go to sleep at night. When you're a raccoon living right here, you're very happy, but some animals would not take this kind of a situation. This is North Central New Jersey, very American. And then, whoa, Central Park, you live in Central Park, and you're a gray wolf, not so good. So of course, you recognize this, of course, this is an extreme example of a matrix that's, we're gonna say unfavorable. So it's Manhattan and Central Park in the middle. Even for birds, eh? Everybody knows that, right? You all heard that towers catch thousands of birds in New York every year during migration. Another repeat, Keller's showing the umbrella species. They like the concept. It's a good idea because I mean, you can't deal with every species. So you pick the umbrella species and you're safe. The other ones will be showing up. Well, 3 different species. Your pillage is at the bottom. It has larger habitat requirements. Therefore, that's you're aiming at the umbrella species for biodiversity. Here's another acronym, MDC, and it's called the maximum diameter circle. When you want to sample your habitat, it's got all kinds of funny configuration. You go into an MDC. And obviously it has of course, in terms of sampling, it makes it comparative, right? So I can compare this habitat right here that I sampled compared to the next one. So in terms of patch, but it also retains some properties here that are pretty important because what's the limiting factor could be actually the width right here. So the length is all right, but I see that it's elongated. So same thing if I were to draw a circle on a sausage, I end up having the functional habitat is actually smaller. There's more room for other animals, but the maximum diameter circle right here. And of course, to understand that, it's just the largest circle you can draw within the habitat patch. All right, so it's just to bring some modesty. People say, "Oh, listen, I got 200 hectares." Well, it depends how it sits in the landscape. If it's just a very narrow band, the NDC you realize will be extremely small. I still have 40 hectares, but it's badly shaped. So very important to realize that this is more likely to be a core area for the animal. Realize that because it's away from the edges. Thank you very much. Here's a concept, the idea of how do they call it? Solid patch. So simple, 2 words for the exam, solid patch. It's a way of managing habitats so that you reduce isolation by creating an actual physical connection. So that's what happened here. So I had a very large patch right here, and then eventually, if I can plant in order to create this right here, if we see that, so that creates a physical connection. Please note for the exam that this patch is actually larger and less suitable than a smaller one. Notice that the connection allows me to have a smaller patch for the animal because it's connected to a larger patch. All right. Very quickly, Soulier 2021, chapter 16 was talking about joint venture approach, just a bit of philosophy as we leave this textbook. Just talking about, and the birds are the typical example, the whales are the same, anything that's international will require a joint venture approach. This is not to be unexpected, just saying that if there's a chapter on it, because it's serious. And that means that it's been really established. Audubon's starting drawing and building museum in the USA a long time ago. And he was a bird fanatic. Don't trust any ornithologists. They are crazy birders. Okay, so they're really serious. They have all kinds of organizations to make summits and manage species internationally conventions in North America. Just to let you know that some of our birds in Nova Scotia end up in Venezuela, so you're dealing with quite a few countries that would have to deal with this. Here I just retained this at the center right here, never mind the rest of it. So you see some kind of a rotation here. So there's a cycle where you start with your what species and in what human context. That's your biological social planning. I call it what's the interface, what species, and what kind of a relationship with human. Your conservation design, your delivery is important and very useful monitoring and research. So as part of the diagram, that means that no, we can't just apply a given management and not follow. That should ensure your job for a little while. And because Victoria asked for it, without further ado, right, Victoria, still with us? I'm going to go through this. This is the very last chapter of this. So thing, yeah, finally, yeah. I agree. It's been fun. Time to move on. I promised I would stall on habitat selection. Again, a very, very large topic, of course. Decided to, without further ado, talk about my absolute favorite animal right here. I gotta treat myself a little bit. So it's quite wonderful that with an animal that's, as you know, elusive, enigmatic, mythical, rarely seen. It was that Wolverine, hardly recognizable, looks like nothing else. That somebody was able to find just a bit of funding from the Columbia Basin Fish and Wildlife Compensation Program. Oh, well, they back, yeah. Pretty good. And then Eric Lofrod from Ministry of the Environment at in BC. Money. And then Selkirk College. Oh, I see geospatial. Look at that. This is the pub friend of Friday afternoon, the GIS person. Look at that. How useful is that? So these three come up with, of course, as you see in the title, multi-scale habitat use. So that's pretty daring, considering that just monitoring habitat in Wolverine would be extremely hard. We'll see what numbers look like. All right, so their intro, very briefly, their justification for the study was that they were worried that the emblem is being affected by multiple use land. So another expression for human intrusion. In some parts of BC. And pretty amazing that somebody was able to find the millions to drive through that research. Because after all, you're looking at BC, and BC is not the most populated. I think Texas has got more human density. So in terms of multiple use, we'll see what we're talking about here. You're looking at seasonal habitat use, which is pretty daring as well. You could do only winter, could do only summer, which is very common. Sorry, cherry flies this helicopter only in March. That's all you're getting. These guys went seasonal, summer and winter. Resident, important was the opposite to resident is say nomadic, transient. Transient is a very good term. Not useful in biology. Just don't know when that thing is going to be a roadkill or transient. A resident, on the other hand, has inspected it, somewhat of a home range and intends to keep it. So resident will inform you on habitat selection, not a transient, correct? So transient could be right in the middle of the highway. And then you're reading this as habitat. Adult is important because the young ones haven't settled yet. So right there is pretty daring. That means that somehow they managed to radio color a whole bunch. Takes about a day to make just a trap to catch one. So, and you're likely to catch 3 young ones before you catch an adult one. Wow. So machine, you're in a camp and you're going to check your trap, and yet it's another juvenile. You're screwed. So these guys did really some serious screening in BC. I just want to show you the general setup taken from Google Earth. So Columbia Mountains is right here. And they compared it to, no, they used America as well, just as a second study set. So and this is where, this is Columbia and America to the north. Somewhat different temperatures, but BC has this that's particular. If you change elevation in the same location, so that you can be in winter or summer. So you can go north in the province, and then you go down in elevation, you're the same condition test. So very lucky. This is what the Columbia Mountains look like. This is a wolverine habitat. Notice that Calgary is right here. And that means you're not very far. And here are the foothills of the Rockies, of course. Pretty down south. And then this is what it looks like. So same mountains, just showing one landscape. And in the end, everybody's wondering where your wolverine is. What they have right here is forest. As you can see, forest has different traits. Then the top will have mountain goats, for example, and the south will have moose, for example. We're looking at large enough species. So that was their food drivers in that study. Is moose driving the wolverine habitat selection? Is mountain goats, and they had a couple of surprises. This is the America Mountains to the north, same idea. Of course, each mountain has got all kinds of, they call it avalanche terrain right here when there's no vegetation. So recent soil drops like these, all over the place. So this is Wolverine country. They want to know where it is in there. So good luck. Too bad I didn't show the scale. Pretty impressive. You got to remember logistic regression is very common in literature for habitat selection. So that means I know I spotted one, I'm not counting the wolverine, I just want to know where it is. So that's occurrence or presence absence is good versus all kinds of several variables. I've seen that in your orals as well. In this case, they simplified the food, the predation risk, and human disturbance. So let's see what they have here. So this is methods as well. They want to prove that they worked hard and they were not biased towards the winter or the summer. So the take home of this table right here is showing they got plenty of locations, whether it's in Colombia or Dominica, and for males and females in the hundreds. So the worst is probably summer males in Colombia, but it's in the hundreds, so very, very safe as well. Try to bring the ADK at the exam. That's called adaptive kernel estimating. So it's a home range. Invariably home range algorithm. Invariably. So as soon as you talk about kernel estimator algorithm. That gives you a 95% confidence around the square kilometers, this one. And I'm not exactly sure from the paper, I'll know next year if the 325 is an average, but still the values are quite impressive. So you're looking at different pointer. Let's try this one. Yeah, so in the hundreds for sure. So the males, huge. Mind you, the township is 100 square kilometers, so you're looking at 7 townships here. Or there could be all this Sudbury for one animal. That's pretty crazy. Quickly, the list is not important, but in terms of pretty ambitious to look at prey distribution because I work on diet of wolverine, and I know that social hair, for example, is a very common item. They didn't go there. You're looking at wolverine. That's if you travel 7 townships and you're supposed to count snowshoe hare. I don't think so. Therefore, they went for the ones that are going to bring some serious energy throughout the winter. The moose you can expect somewhere, and sure enough, it's in the diet. Caribou as well for sure. Mountain goat is interesting as well, although I don't know, just maybe 1 or 2 of those in the diet. So, but wolverines, they're curious. If they smell it, they have to go. So they're travelers. The marmot, pretty interesting. Snowshoe hare is right here. Apparently, they put it in the small mammals and the beavers. So yeah, it wasn't. Somehow they found indices of beaver, and notice that some prey applied only to the northern part, which is Dominican. In terms of the elevation, the ruggedness was used as well. And then human use snowmobiling and backcountry skiing quite a bit. It says Columbia only because it's in the south. You're off Calgary, you're going out for a day, and that's where you have that Rebel Stoke around that area. I suppose it's extremely touristic. That means everybody's a millionaire driving a BMW and going, taking a chopper to go skiing for the day. But we're looking at thousands of people doing that activity out there. So the roads themselves. The picture is more interesting than anything else, although I should have made it way bigger, but essentially it's just showing a multi-scale. So that's in one word, that's showing a multi-scale approach. So for any given location, they analyzed the habitat where the animal was found. They took a large circle called the landscape, and they defined the diameter that's over right here. So right here in kilometers, if you're looking at landscape in males, for example, it ended up being 7.6 kilometers if you're at the landscape scale. In other words, you move out and you sample some more. In a very large area as well. Meso is smaller, and then fine is smaller as well. So for this is just methods, just to show that, yeah, they're not the same. The meso is not the same as a fine scale. So they were careful about that. That's excellent. And that's true for both areas. The distance is very important in order to make it random. So have a look. I have a wolverine. I want to know what it responds to. Is it because there's a house next door? That's fine, right? Fine, great. House next door. That matters. Or is it because the meso is forest? Maybe it responds to the fact that it's forest. Or maybe it's the fact that there's no city around at the large landscape scale. All right, so this is a larger circle, and then of course they move out quite a distance in order to sample what they call the random. So they pick a random area of the same size. The results quickly, males responded to the food hypothesis. So whatever values they gave, of course, moose is a plus, caribou is plus. Males apparently were found where they were more likely to find food, their food, the food that were selected. And this comes down to the same thing, a valid bottom four. So there's nothing too revealing about that. This is not the mountain goat. A handful of animals are usually all the mountains above tree line, right? Your wolf is mostly of a forest, and then they'll go up just to check out a single mountain goat every now and then. But males right here in the winter are more expected to be around the lowland. Remember those Google Earth pictures. And males didn't like the helicopter skiing areas. The females were more complex, and that's not surprising, and it's a good thing. That means they're very careful, so everything matters for them. So you need a combination of food predation risk and human disturbance in the right amounts, of course, maximum food, minimum roads. Human disturbance is your choppers. Flying in, maybe a company might have, who knows, 8 choppers in and out. They know where the avalanches are, so they bring their tourists to one area. So suddenly you got a corridor of choppers going uphill up the mountain. They don't like it, neither did the males, but these ones respond to all of them. So they were associated with alpine and avalanche environment. So that's pretty quiet, but look, it's food as well. So hoary marmot, that comes out of nowhere. I didn't think there were enough to feed female wolverines, but they like it. Super cool for niche separation, by the way. The male stand at the bottom and said, now I'll take care of the big large moose. And the female says, you know what? I'll get myself a little hoary marmot. And Columbia ground squirrels fall prey as well. Roads are negative for females as well. In summer, that's not surprising. They're probably having a litter, so they're really shy at that point. So there's nothing too surprising about this. All right. So males are more food driven. Females are more complex. The distance travel, very interesting to find out if it mattered. And they said, what if we sample too late every 100 days, every 3 months we go and fly over our wolverine? Is that going to matter? And the answer is no. Because let's say that I wait, Jerry is gone to Cuba. He's on the beach. I wait 3 months for him to fly me over my wolverine with his radio collar. I say that thing's going to be gone. The answer is no, because it traveled exactly the same distance as if I was there 3 days earlier. At 3 days interval. All right. So that's the bottom line. Second observation is that the white circles are higher because those are the males. So I'm sure statistically the males travel more than the females. Nothing surprising about this. Notice the values are pretty interesting as well. So you're looking at 20 kilometers, 15 kilometer distance. So even within 24 hours, right? So some travel crazy. I just want to introduce you. Let's see. I think we're almost done. If you're patient enough, I'm going to go through this. Table 4 is shown as well here. All right. So this is a full table showing, of course, results of logistic regressions. I want to introduce you to this term that I should have highlighted right here, the delta AIC, or the AIC itself. Another acronym for your exam. I could show it as AIC or delta AIC, same thing. One is more mathematical. Actually, 2 different calculations. So AIC means Akaike Akaike information criterion. learned that it's a Japanese. Name, unfortunately, his last name was Akaiki. And okay. So, well, whenever he came up with that, he did well. I hope he has dividends on that because everybody else is using it. Now, I want you to understand for next interview what it is, what it does. It measures error. So your value in AIC will go up if there's more error. Error in the model. That means it doesn't predict all the points. Remember how a regression has a dispersion of points around the line? That's always error, right? So why did they go into call it information criteria? Because it's based on information theory that says that the representation of a process, such as habitat selection, say for example by elevation, look at habitat selection, so what they select by habitat selection elevation. And I build a model with different variables. I got elevation, moves, different variables. I mix them together into logistic regression. It's never 100%. This is not, it's real work. So it's never going to be exact. And information, see keyword, information will be lost in each model. So I think it must have come from psychology, this kind of perspective on modeling. So that's why it's called a information criterion. It's a mathematical algorithm, of course, that gives you an assessment of the amount of error. The amount of error. Right? So in other words, this bar right here, the higher the value, the more error. All right, so this is as simple as that if you want for now. And the beauty of the AIC is that it rewards, I hope you're somewhat familiar with the term goodness of fit, right? This is what I'm talking about. You got a regression line, and if your points fit on the line, that's perfect fit. And most that will rely on goodness of fit. The points fit on a predictor, a line that you think is, algorithm calculus for you. So, whatever you get is this. So it does, AIC will increase with better fit. That's what it means, rewards goodness of fit. So it reads, these values reflect the goodness of fit. The more the better. But it also penalizes it for a number of parameters. At some point, they recognize that if you measure everything, you should be able to have perfect fit. So they said, don't cheat and don't try to put so many variables together, because eventually you're going to get right on it. So the problem I have with multi-dimensional like this one, for example, right here, this line right here, is that even if I know this is significant, I don't know how I can manage from there. It's like saying, well, everything matters, okay. Well, good luck. You were trying to pinpoint a variable that could help you, so you're stuck with all variables measured. You got a perfect fit, but you still can't manage. So it's a give and take. The bottom line is not just quickly. So this is one of their figures right here. Of course, I'm looking to see. I like it, and I find it a nice paper because you could go only with likelihood tests, and you could go with stats. Unidimensional has some merit to it. They're redundant because after all, there's only one goal here, is to find out if where I find Wilbur, used is the same as any other location. Used versus random in all possibility, female summer, female winter, and so on. Of course, it reads very quickly, and I was able to find this one where females in the winter will respond differently to glacier and moose. So the way I read into it, this is the female in the winter. Obviously, it's in the dark, so it likes moose a lot, and glacier, not so much. Plenty of glaciers available, but no. No, thank you. The rest seems pretty similar, so you see how wildlife sometimes will help you write a shorter discussion. Too bad if it was to respond to everything. Really hard to do. This seems to be a contrast as well. Did I highlight this as well? Yes, I did. So right here, moose at the landscape level. So it's the landscape moose habitat is the meso intermediate. We call it regional maybe. If the meso is something that's perceived by the animal, and definitely this is random. So this is what you got in the landscape. Not so much of a moose landscape, but regionally, yeah, for sure. And look, definitely going for moose more than available. This is really habitat. This is habitat selection right there. The rest seems very similar. You've got this acronym right here, RSF. We've seen that before. It's called a resource selection function. Resource selection function. And this one is spatially explicit. See, the geographers, that's what they do. They can't generalize because they always work in a confined space. And that's called spatially explicit. That means that whatever is drawn here does not necessarily apply or will not apply to anywhere else. Like saying, oh, yeah, this is good for koala, but only in this island. So same idea, of course. So this is useful for BC, from BC to BC people, by BC people right here. So showing that in the study area, if you want to know the suitability of habitat or its distribution, you're going to look at this map. Sorry, pointer right. Nope. A and B. This one is probably Colombia, and the other one is probably America. Oh. Same thing, you know. This is America right here. Same idea, of course. The idea that they put all of that together in the same paper is pretty cool. Unfortunately, many paper will just use only the multivariate analysis. All you can say is, yeah, it's pretty supported. You know, we haven't looked this season, this and that. No, this paper is quite comprehensive. If I'm not mistaken, from 95 to 2003, looking at almost 8 years of helicopter time, radio collars on a whole bunch of animals. As many adult females as they would have adult males. Good luck with that. And then who's the collars? They got the data. And it took them 4 years to write the paper. Good luck. So quite extensive work right there. Not surprising. So human disturbance, nothing too surprising about this, although there's controversies on that. Some people think that wolverines are persecuting trappers, so that they're attracted to camps. No. It says right here, additional focused research for sure. So exactly what in the moose landscape is driving further research for sure. And this is referring to the last graph that they showed right here. Just they provided it. So in other words, these graphs right here couldn't use in Ontario. Of course, it's for BC. 2 minutes on pseudo replication. I'm keeping you guys, eh? I'm sorry. and I want to finish this. It shows a soil replication is important. It's very understandable. It's when you have to stay away from it for sure. I just had fun with a little display here of two sampling possibility where I have all occurrences, and the next one here, systematic sampling. One of them has pseudo-replication. So let's say that this is a habitat selection, and this is a trail, and I'm sampling here and there. Obviously here, I'm putting a lot of, for example, if my radio call is working that day, I'd say, oh, I might as well take some data. So I'm reading all kinds of location on the same animal. I'm on the same day. Well, actually, it's a time of day right here, say 2 a.m. I could pick this one, 1 p.m. Decide to go for all batteries are fully charged. I'm picking all kinds of habitat. The animal's still in birch. The animal's birch. Come back 5 minutes later. The animal's still in birch. Okay, he likes birch. You're cheating because you're summarizing a year over bias towards points that are not independent. So that's what you need to remember, is that pseudo-replication is a lack of independence. So in other words, your points are dependent. All kinds of example possible for sure. And systematic sampling will correct this bias. This is what I'm showing at the bottom line right here. I don't care. I can take my habitats. I read the habitat. But when I clean up the data, I let go of the ones that were next to each other. So it's if I'm looking at McKellar right now, no or time budget, and I sample only now, I'm going to say this animal works on the laptop 24 hours a day, right? Because I took 5 observations, 2 close in time. So the idea of independence right now. So one way is to make them a posteriori. You can subsample your data just to make them independent. Now, what guarantees the independence? There's no guarantee. There's no guarantee. But what you want to do is give it enough space for enough time. All right. So same thing. I'm sampling habitat right here, and I'll finish on this. If I go too small, I'm always on birch, and then I finish my study. I was only on birch. So I have to give the habitat a chance. I have to give the animal a chance to move or to change location. All right. Like measuring your blackberry, you know, average generation very well. It looks like this thing lives in the den. Yeah. That's the end of chapter 8. That's the end of the material. So thank you very much, guys, for your patience. I'll probably, I don't know, raise your hand if you want to show up for the next class, yes or no. Otherwise, we could go. Yeah, send me some feedback by email, and I'll go with the flow. I don't care. All right. Thank you.